So we got a function L of t in this chart. L of t is the rate at which cars are leaving this parking lot. E of t is this other function that they've given us. That's the rate at which cars enter the parking lot. We're talking about the 12 hours between 5 a.m. and 5 p.m. First thing they want us to talk about is the rate of change of E of t at t equals 7. Well, that's just E prime of 7. That should be easy enough since this is a calculator question. You just have your calculator tell you what the derivative of that is at 7, and the answer is 6.164924. And then they also ask for units, and the units are per hour, right? It's cars per hour for, well, it's cars per hour for E of t, wherever it is, the rate at which cars enter, cars per hour. And then squared because we're taking the derivative with respect to t. So cars per hour. And that is worth 1 point for the whole thing for A. You had to have the units. If you didn't have the units, if you just had the number, you did not get the point. Okay, everyone good with A? B, the integral from 0 to 12 of E of t. That's what we've done a bunch of times with these rate questions. The number of cars that enter is just the integral of the rate at which they enter. So the integral from 0 to 12 of E of t, and they said to round it to the nearest whole number, came out to be 520. They gave you 2 points for that one, 1 for the setup and 1 for the answer. If you didn't round it, they didn't give you the points for it. Had to round it because they said to. Everybody good there with part B?
Yeah.
Great. All right. Part C, we're going to use a trapezoidal sum with 4 subintervals to find the integral from 2 to 12 of L of t. So this particular trapezoidal sum has to be done with each trapezoid separately because the intervals are 3, 4, 2, and 1. They're not equal subintervals. So we'll just do base 1 plus base 2 divided by 2, multiplied by 3, and then these bases added together divided by 2, multiplied by 4, and so on. So our basic setup here for part C should look like, let's see, we have 15 plus 40 over 2 times the 3. And then we're going to have 40 plus 24 over 2 times 4. And then we're going to have 24 plus 68 over 2 times 2. And then we're going to have 68 and 18 over 2 times 1. And do a bunch of arithmetic, and you get 345.5. They gave you, and they asked you to explain what this means. This is just the number of cars that leave. And within the context of the problem, that leave from 7 o'clock a.m. t equals 2 to 5 o'clock p.m. t equals 12. 3 points, 1 for the setup, 1 for the number, 1 for the explanation. Everybody good with part C?
Yep.
Great. All right. And then part D. Part D should have been pretty straightforward. This was actually a pretty easy rate question, I think. For t equals 0 to t equals 6, they charge $5 for each car. And from 6 to 12, they charge 8. They want to know how much money. Well, just take the integral from 0 to 6 of E of t and multiply it by 5. And then take the integral from 6 to 12 of E of t dt and multiply it by 8 and get some number. And they said to round that to the nearest dollar. Well, yeah, there you go, to the nearest dollar, 3,530. Pretty straightforward there. They gave you 3 points for that also. 1 for knowing that you needed to integrate E of t, 1 for the correct constants out in front and the correct limits on both of them, and then 1 for the answer. Everybody good there with all of that first question? I feel like that was a pretty easy rate one overall. All right. And the second one here. Hold on one second. I gotta do something for my kid. Okay. The second one here, we're given a function f of x, another function g of x, and another g of x squared. So f of x, they actually give us the function. G of x, they don't. They do give us the area of region R, though, as 3.24125, and they give us the area of region T as 5.32021. And then the first thing they ask us is to find the area of region S. So region S is the region between F and G. So region S should be the integral from 0 to 3 of F minus G. Well, we don't have the actual function for G, so we'll just say it's the integral from 0 to 3 of F of x dx minus, well, the integral of G is just the area underneath G, which they gave us, 3.24125. And you'll use your calculator, you'll integrate this horrible function from 0 to 3, subtract 3.24125, and get 4.919585. Everybody good with part A?
Yes.
Cool. All right. Part, oh, and they gave you 3 points for that. So kind of them. 3 points. 1 for setting it up 0 to 3 of F, 1 for using this area of G, and 1 for the answer. All right, part B got a little bit more complicated. So for part B, we're going to take region S and we're going to revolve it around the line y equals -3 and find the volume. So first off, for part B, we know that it should be pi, and it should be an integral of our outer radius squared. And since we're going around y equals -3, the outer radius is 3 plus f of x squared. And we're going to do that from 0 to 3 minus the inner radius. And the inner radius is 3 to get from -3 to 0 plus g of x squared dx. Everybody good with the setup there?
Yep.
Wonderful. So then the integral of 3 plus f of x squared from 0 to 3, that's just some number that we'll get. I'm not going to bother with that right now. I'm just going to keep rewriting that. But the other part, we're going to have to do some extra work with here. So 3 plus g of x squared is minus a 3, it's not minus a 3, minus a 9, plus a 6g of x, plus a g of x squared. Everybody agree with that? If I distribute out 3 plus g of x squared. I hope. What's the integral of 9? Okay, 9x is the integral of 9. Good work. And then what about 6g of x? Well, the integral of 6 g of x is just the area under g of x times 6. So that'd be, if we distribute the minus 6 times 3.24125. And then minus the integral of g of x squared, which is 5.32021. Everybody good with that or no? Any of you still there listening or no?
Yeah.
Oh, okay, just making sure. All right, and this 9x still needs to be evaluated from 0 to 3. So we're going to have pi times this integral of all of this piece minus all of this stuff. The pi is being multiplied by everything in here. And we'll just evaluate all this out. This is 27 minus this, and then do your integral and subtract and multiply by pi, and you get some number. And that number happens to be 156.263 709. Good or no? All right.
Good.
Oh, good. Okay. 1 point for this. 1 point. Actually, that's not true. 2 points for the right setup up here. 1 point for using this area. And, well, actually, 1 point for using these two areas. And then 1 point for having the right limits, constant, and the right final answer. And then part C, it says region S is the base of a solid that has rectangles coming out of it. And the length here is 7 times the height that goes perpendicular to the x-axis. So the area of the cross section is 7h squared, where h is equal to f of x minus g of x, just the distance between the two functions. So if we want to find the cross-sectional volume, the volume should be the integral from 0 to 3 of 7 times f of x minus g of x squared dx. And that was worth 2 points. 1 for what's inside and 1 for the whole rest of it. But part C should have been pretty easy. So part B on that one was the harder part, I guess. But not too terrible, I don't think. How do we do with those? Do we do okay with those?
Yeah. Could you go back to part B of number 2 for just a second?
Sure.
Thank you. Okay, thank you.
No problem. Anybody have any questions on any of that?